We now have this LeetCode challenge called reverse integer. Given a signed 32-bit integer called x, we have to return x with 8 digits reversed. There is a chance that the value is going to overflow, meaning it's going to go outside of the allowed memory space for that integer, and in which case we need to return 0. For example, if the input is 123, we need to return 321. So it's the same number, but the digits are reversed. If we get a negative number like 321, then when we reverse this, we should normally get 123. So 321 becomes 123, but notice that the negative sign is still at the beginning. When we reverse a number, we only have to reverse the digits, not the sign of the number. If we get 120, we get 021, but by default or by definition, integers do not have a leading 0 digits. So we simply return 21 for 21. So the leading 0 has been removed. My implementation for this challenge is like this. In my LeetCode solution, I'm not performing any sort of algorithm directly on the bits of the number. You can do that if you want a faster results or better performance results. In my case, because we are only working with a single integer and it's not like a super long array of integers, I'm fine with converting the integer to a string and then reversing the digits of that string based on some simple condition and returning the string converted back to integer form. So how I'm doing this is I use the toString method under the std namespace and I pass it my x parameter. This parameter is the integer that we want to reverse. It's the same value as x, but this time around, the data type is a C++ string. Now that I have this C++ string called converted holding the integer value, I need to verify if there is a negative sign at the beginning. So first what I do is I grab the first letter from that string and I'm using the substring here. So I extract from index 0, 1 character, that is the sign of the number. It could be a negative sign or it could be a digit. Next up, because they specify here that reversing x might cause the value to go outside the signed 32-bit integer range, I need to use a try-catch block, meaning that when I'm applying my logic here inside of this function, there is a chance that I'm going to get a memory overflow. And this is going to throw an exception. To handle that, I'm using a try-catch block, so that if what I'm performing here causes an exception, my program is not going to crash. Instead, I can capture that exception or that error using this line here. This means I'm catching all exceptions and I return 0. In the case this fails, I'm going to return 0. And here they say if we have an overflow, then we have to return 0. Inside of this try-catch block, the first thing we're doing is checking if the sign that we extracted here, is it a negative sign or a hyphen? If it is, then we're going to set start to 1. Otherwise, we're going to set it to 0. The data type for start is size t because I intend to use that when I'm extracting the values from my string value here. So string answer, I'm calling it ans for the answer, is going to be my string. The number that was converted to a string is going to be that string. And then we're going to extract from the start position all the way to the end of that string. So how much we extract depends on whether we have this negative sign. If we have a negative sign, then we set the value of start to 1, meaning what we're going to extract here is going to be from index 1 until the end of the string, because index 0 in this case is going to be the negative sign. We don't want to reverse the negative sign. I believe that's what I explained right here when I said the negative sign stays at the beginning. It stays at index 0. So if we have a negative sign, we want to extract from after that character, that hyphen, all the way to the end. If we don't have a negative sign, it means that the value of start is 0. And when we are extracting the answer here, what's to reverse, we're going to extract the full value, like the full digits. So in this case, we're going to extract the full 123 or the full 120. In case we have a negative sign, then we only extract that part. Now that we've extracted the correct value, we can use the reverse method from the algorithm library here, and we pass it the beginning of the string that we've extracted. So this is an iterator, and we pass it the end. This is the iterator pointing to past the end of the string. And that's how you can reverse a string. And it's an in-place algorithm, meaning that we don't need to store the results anywhere. It's directly performing the reverse logic on the string itself. Now, if start here was 1, meaning it was a negative value, I'm going to use the s2i function, which is to convert a string to integer form. I'm going to use that and convert my string back to integer. So this here is the s2i function. If you don't know what it does, it converts a string to integer, and the complexity, meaning the performance of that algorithm, is linear, usually based on the number of characters. So in this case, I'm going to grab my sign, for example, negative sign, and I'm going to prepend it to my reversed value. And I'm going to convert this whole thing to an integer. So that is what is going to give me, for example, this 123. I'm going to prepend this negative sign and convert this whole thing to an integer. Otherwise, if start was 0, meaning there was no negative sign, then I'm just going to convert my reverse value here to an integer. No need to prepend anything because there's no negative sign. In this case, this here is a positive number. So that's how we get the value. We check if there is a negative sign. Otherwise, we decide from where to extract the proper values to reverse. Then we perform the reverse logic. And finally, we decide if when we are converting the string back to integer, we need to prepend a negative sign or not. In case this fails because of an overflow, we can capture the exception and return 0 as they specify right here. So now let's run this code. We've passed this sample test case 4 milliseconds, so it's just fine. We don't need to worry too much about performance. And when we submit it, we see that we've passed the test cases. Now, the speed of the algorithm on LeetCode is not fixed. So for example, previously when I ran this, we had much better performance. We had 4 milliseconds, and the ranking for the performance, the runtime, was pretty good. So it's just fine. I'm not going to bother really about the bits or other methods of speeding up my algorithm, because we just want to understand what this problem is and how to solve it. But you're welcome to optimize this and let me know how you did it. So for now, that's it for this coding challenge called Reverse Integer from LeetCode. If you like my solution, please subscribe to my channel, and I'll catch you next time.